Okay, great. Welcome, everybody, and thanks for giving up an hour over your lunch break for one of our monthly webinars from the NICE programme. And this month's theme is there on the slide: circular solutions for nature and the economy. A huge topic, but we've invited three speakers to provide a bit of a stimulus from very, very different perspectives to get us started in a conversation that we can continue after the event in whatever shape or form that we think is appropriate, and people can get back in touch with us or you know, find some forum in which we can sort of expand and explore further. It's a really interesting topic. Anybody who's sort of looked into the circular economy in any depth will know that it features nature and natural capital, and economy features strongly as a guiding principle and in the title. So, you know, what does it mean when we start to talk about circular solutions? What are they, and what do they look like, and how do we critique them, and how do we evidence whether they're doing what they say on the tin? So I think next slide, Imogen, just gives a bit of housekeeping. Apologies for the cough. I think I've had COVID. But I'm not sure. But I've developed this terrible cough for the past 3 weeks. I'll try and sort of keep my talking to a minimum. So the recording will be available on the website afterwards. Keep your camera off if you don't want to be seen. Keep your mics on mute. Otherwise, we can close them down remotely if there's any background, and post your questions in the chat box. And be willing to come in on the mic if we can get through the questions, probably from about half 12 onwards. So each session is about 10 minutes there or thereabouts. I'll only come back in on the mic if I feel that the speaker is overrunning or we're going to run short, get short on time. So I'm going to ask each speaker to introduce themselves. We're going to kick off with Carl, who I've known since he was a young lad in the late 80s, I think it was. Shows you how far back we go. So Carl, you can introduce yourself. Tell us who you are, your organisation, and what you do on a daily basis around this topic. Okay, over to you.
Yeah, morning, afternoon all. So I'm Carl Fuller. I work for the Environment Agency. I work in a team called the National Environmental Assessment and Sustainability Team, and my role is the National Sustainability Performance Advisor, and I'll explain what that means in just a moment. Now, can I move this on? Imogen, I'm just going to ask you to move the slides on, if that's okay.
Yeah, apologies, it's not giving me the option to share it. Let you do it.
So just next slide, please. So the Environment Agency has, in a sense, sort of two sides to it. This is a very simple explanation. You'll understand part of it deals with environment and business and regulation and that sort of thing, and the other part deals with flood risk management. And I sit in the bit that deals with flood risk management. So this is a slide of Cockermouth, actually, in flood, which has two rivers that has a confluence within Cockermouth, and so it's very vulnerable to flooding. So our role is to try and either prevent these sorts of incidents or make communities more resilient to them. And my role in particular is to try, when we're doing that work, is to try and make sure we do it in as sustainable way as possible. Next slide, please. So the traditional approach to flood risk management has been what I would call the sticking plaster approach. So when we identify where there's a problem, we try and provide a solution in that problem, and generally that means quite a lot of concrete and steel and traditional construction sort of activities. It involves a lot of engineers as well, but we're increasingly having to look at alternatives, and the reasons are it's expensive, and I'm sure you understand, you have to make a business case for each time you do a project, and a lot of the projects that have got lots of benefits and therefore are easy to pay for, we've sort of done, and we're now on the ones that are a little bit more on the margin. It involves a lot of carbon, and we're trying to reduce our carbon. We have a a net zero target within the Environment Agency by 2030, which is an interesting challenge. But also it's increasingly untenable. If you move to the next slide, Imogen. So this is a project known as Perry-Barr and Witten. And the interesting thing about this project is this wasn't the original plan. So this site is to the northwest of Birmingham, and it's on the River Tame. And the idea is to reduce flooding in Birmingham. And the original plan was to build walls in Birmingham, concrete walls. But when we modelled it, we found those walls would have to be in the region of 3 meters high, which is both wouldn't look very nice. It would completely cut off communities from the river that flows through their areas. But also it was in the confines of Birmingham, narrow streets and streets next to rivers and so on. It was technically impossible to build a 3-meter wall in those locations. So we ended up building this flood storage area. So when the Thames in flood, this area will flood. You can see there's a sort of gate across the river, will reduce the flow going through that gate and cause this area to flood. And this project was just completed this year, so that's why it looks all shiny and you can see all the paths standing out on the slide. Next slide, please. The other thing with flood risk management is we're dealing with natural systems, and we have our fair share of causing an impact on those natural systems. So this data is on this slide is from our most recent river basin management planning cycle, and that's showing us that there's rivers are not necessarily in a good state. We've seen plenty in the news about that. But one of the things river basin management planning does is to identify the reasons for those rivers not being in a good state. And you can see from the slide, 41% of rivers have physical modification as a reason for it not achieving good status. 50% of riverbanks and beds are physically altered, and 50% of coasts and estuaries are heavily modified. This slide is a river in Norfolk, and you can see it's in ecological or biodiversity terms, it's a bit of a desert, and that's one of the effects flood risk management can have. So the challenge is whether we can manage flood risk, but in a way that regenerates natural capital. So next slide, please, Imogen. So how do we use those natural systems to our benefit? And I guess when I was thinking about this talk, one of the things that interested me is that often the circular economy is about zooming in on particular materials or particular products and thinking about the detail of those products and how we make them more circular. When it comes to flood risk management, and particularly that thinking about how we regenerate natural capital, is actually about zooming out and thinking about the wider catchment. So this report on the right-hand side is the Eden Catchment Plan, which is fundamentally about trying to reduce flood risk. But because the River Eden, which flows through Cumbria, is a very rural area, they have to think about how they use natural capital to reduce flooding, because it's very unlikely that any engineered schemes will be affordable, apart from in Carlisle, which is at the bottom end of the catchment. So what does it look like in practice? I've got a couple of examples for you. Next slide, please, Imogen. So we've been doing some work with Peter on what the circular economy looks like for flood risk management, and one of the case studies we focused on is this one called Ellis Meadows, which is in Leicester, and this is part of a multi-phase scheme to try and reduce flooding in Leicester. And again, the original intention was to build some walls, and they went, that's really expensive and unaffordable. And so they started to look at other options. And Ellis Meadows is all about reconnecting the river with its floodplain and using that opportunity to create some habitat and create some areas that people could walk on and reconnecting cycle paths, and it became a huge amount of additional benefits that we provided with the scheme, as opposed to just providing a flood risk management resilience. So that's one example. Imogen, next slide, please. This scheme is in Warrington, and again, another multi-phase scheme. So it included some wall building, some habitat creation, and in this particular case, it's a park area in Warrington that, again, we created into a flood storage area. But as part of that, we did regeneration work on the parkland, really, and turned it into a much more interesting place from a recreational point of view. The interesting thing about this project is the area that was responsible for it in the northwest did a retrospective natural capital assessment of the project. So if we just move on to the next slide. And this is what they found, that by creating this additional resource for recreation, we increased recreation visits to 350,000 annual visits, 175,000 active visits per year, and you can see that monetize the benefits of this on the slide. Air quality benefits amounting to £242,000 of benefit, and also carbon sequestration. The flood risk benefit is, in a sense, you'd have got that whatever solution we'd have come up with, because that's the whole point of the project, is to try and provide that flood risk benefit. But it's those additional benefits that are really interesting for us when we adopt natural capital approaches. Next slide, please. So does anybody recognize the quote? Okay, it's a line from Big Yellow Taxi from Joni Mitchell. And you could almost extend this and say you don't just don't know what you've got till it's gone. But when it's gone, then you tend to forget about it and you have to rediscover it. So there's some really interesting things around this natural capital side, and rediscovering things that we knew in the past, but we've sort of forgotten about. And an example of that actually is a historical one. So Sheffield University have been doing some work to demonstrate that old techniques for building that were used in excess of 100 years ago are far more flood resilient than approaches we use now. But I want to focus on something else. So if we just go to the next slide. And this is the title. So beavers. Beavers were hunted to extinction from the UK over 400 years ago. And some of you may be aware that there's now a program of trying to reintroduce them, or at least run some trials to reintroduce them. And the primary motivation for that is actually a biodiversity one, because they are just amazing ecosystem engineers, and the biodiversity benefits you get from just having beavers in a place is fantastic. But really interestingly, is that they're also a flood risk benefit. So if you just click again, Imogen, we should get some words up hopefully. So there's an academic paper looking at 4 sites around the country, looking at what having beavers there meant in terms of flood risk. And what they found was that, and the pattern was true across all the sites, was that it reduced the total storm flows and reduced the peak flows in the rivers and the watercourses they were affecting. It increased the time between the peak rainfall and the peak flow in the watercourses. Flashiness of the rivers, so that difference between normal flows and high flows was a much reduced gap, and it even reduced the peak flows in the wet season. So they were they were just as effective, if not more effective, in the wet season. And I'm not suggesting the Environment Agency is about to start suggesting a flood risk solution of releasing beavers into a catchment. But it just brings to mind that actually a lot of what we do in flood risk management is probably trying to solve the problems that we've caused ourselves in the past. So a lot of the problems are around how we manage land or use land, and beavers are just a really good sort of analogy of how we hunted them to extinction, and they were actually bringing loads of benefits that we didn't necessarily recognise at the time. So sometimes the most circular solution would be to stop causing ourselves the problem, rather than think about how we build something or construct some sort of solution to solve a particular flood risk management problem. Did I fit that into 10 minutes?
11. Well done. Okay, so my takeaway from that, Carl, if I just sort of summarize, is you've got a net zero ambition and you ain't going to hit it if you keep pouring concrete and steel into the ground, and there's other solutions, and you take a big systems perspective along numerous dimensions. I'm sure Ian will have something to add to that in his presentation after we've heard from Susie. So that's great. For those who asked about slides, the slides are available. The recording is available, subject to the speakers giving permission for the slides to be sort of uploaded separately. So thanks for that, Susie. I can't even pronounce your job title, so why don't you tell us who you are, what you do, and why we invited you on to this webinar.
Thank you, Peter. It's eukaryotic microbiology, which is a bit of a mouthful, admittedly. So Imogen, if you go to my first slide, please. First up, I've been invited, I think, because I'm funded by the CE Hub. But I'd also like to acknowledge Bamboo Clothing, who have supported my lab with the provision of some very large pants over the last couple of years. So I'm an academic, I'm a research academic at Kingston, and my research question that our lab addresses is probably different to everybody else's on the planet, because we're asking whether we can eat our own pants. And I will explain why we want to do that as we go along. So next slide, please. The problem that we're looking at is textile waste, which is a massive problem. It occasionally hits the news and then kind of gets forgotten about again. But actually, globally, we produce a huge amount of textiles, quite a lot of which is for clothing. And the process itself is very environmentally damaging. But we also have to consider what happens at the end of life of those clothes, and quite often the shelf life of them, if you like, the actual use of them is very limited. And something that has made this problem a more thorny issue is that over recent decades, the majority of our clothing now contains synthetic fibres. So those are things that are petroleum derived, so horrible carbon footprint coming into them, but it also means that things like nylon, polyester, elastane, spandex, lycra, all of those are things that we use in our clothing that are actually synthetic and therefore very hard to break down. And the fact that we have clothes that are a mixture of these makes them quite a difficult challenge when it comes to recycling. At the moment, about 1% of textile waste is recycled into something that is of equal value. About 12% goes into something that is of lesser value, so things like rag rugs are made, but over 70% of textile waste is still incinerated or sent to landfill, which is a huge problem, because obviously incineration has a knock-on effect of air pollution problems, and because of the presence of these synthetic fibres, when they are broken down, what you generate are microplastics that then leach into the soil and water. So it's a real problem. The reason that I've got a whole load of pants up there is because pants are a paradigm for us. Pants contain elastane, which is what makes them fit. They're stretchy and they're comfy. And typically people wear them to complete destruction and are too ashamed to put them into a recycling scheme. So pants are a really good paradigm for a textile that is difficult to recycle and that typically goes into landfill. Next slide, please. I feel so weird saying that. reason that we're interested in them is because we work on fungi. So we work on a particular group of fungi called wood decay fungi, which are a very diverse group. But the things that they have in common are that they can metabolize cellulose, which is what cotton and bamboo viscose are made from. So anything that's a natural fiber textile is typically made from cotton or similar. So those are cellulose. And the other thing that wood decay fungi can metabolize is lignin. Now, lignin is a polyaromatic compound. It's very hard, and it's what makes trees hard and enables them to grow tall. So the difference between something that's leafy and small and something that is bigger and harder to break down is the lignin content. Lignin's not something you can break down with enzymes. It's something that requires quite a complex chemical reaction, and the fungi are masters of doing this. The only other thing they need is a little source of nitrogen, a few other little bits and bobs, but predominantly the wood decay fungi will chew through anything that is composed of cellulose and lignin. And the reason that that is very relevant is because a lot of the petroleum derived synthetic fibers have a passing similarity to lignin. They're polyaromats. And that gave us the idea that actually maybe fungi would be the answer to getting rid of textile waste. If you go to the next slide, there are other reasons why fungi are a good idea as well. So fungi are very good at growing and exploring the forest floor, and that makes them ideal for growing through what is a solid pollutant. It's very difficult to solubilize textiles. It's very expensive. So if we've got a bioremediation agent that can actually grow through our waste product, then that's a really good thing. And we also know from previous work that this group of fungi are very good at metabolizing azo dyes, which are really common in fashion, and they are also aromatic compounds. So next slide, please. Our first question right at the start was, can we grow any fungi on waste textiles? And the answer very quickly became obvious that yes, we can. And we can grow a whole range of different fungi on old textiles. So on the left of the screen here, you've got our black starting material. It's dyed with RB5, which is a very common azo dye. And the little rectangle in the middle is a chip of wood that's been pre-colonized with a particular fungus. So you take that chip, we put it on the fabric and let it grow out and see what happens. And as you can see, different things happen. But over time, the take-home message was, yes, fungi will grow on old textiles. They're quite happy utilizing this. If you go to the next slide, being a microbiologist, I like knowing what things look like close up. So the image on the right is a light microscopy image, and the white kind of feathery stuff that you can see is fungal mycelium, and then the darker black threads are part of the fabric. And you can see that the whole thing has taken on quite an orangey red appearance because the fungus is metabolizing the dye straight out of the fabric. And if you look at the left-hand image, that's zoomed in again. It's an electron microscopy image. And that one, you can see the white threads are the fungal hyphae, and then the bigger, thicker threads in the background, that's bamboo viscose. It looks slightly different to cotton, so you can tell the difference, but that's essentially this fungal layer growing right across and through the fabric, which is exactly what we wanted to see. If you go to the next slide, please. So we noticed that there was a difference between these two. That top one, or start with the right hand side actually, that is a brown rot fungus. It's a serpulid fungus, and although we never saw a colour change on the textile, our assay demonstrated that it was actually pulling some of the dye out of the textile. But there were very different ecologies between these two fungi that we were using. And the one on the right is a hypholoma. It's a white rot fungus, very different chemistries that it uses. And the hypholoma is exceptionally good at metabolizing the dye right out of the textile, to the point where, as you can see, it's not really black at all. It's kind of got a yellowy color over 8 months. So if you go to the next slide, our next question was, can we valorize these old textiles? Can we? The majority of old textiles we don't keep in this country. We export our problems to low and middle income countries. And so here you have the waste and you deal with it. So we were very much looking to see whether we could develop something that was low tech, but that would give those old textiles value particularly, we were thinking, well, if we can grow fungi on them, maybe we can grow mushrooms for human consumption on old pants, hence the question. So if you go to the next slide, we had a bit of a choice, because actually mushrooms are something that are eaten very widely across the globe. So we needed to be able to choose which fungi we were going to take into the lab. So we looked at the genomes initially and said, well, which ones have the kind of enzyme complement that would suggest to us that they'll be able to break down the things that are in the fabrics that we're looking at. And we came up with these 4. So from the left, you've got the button mushroom, the shiitake mushroom, the king oyster, and the common oyster. And they all have the kind of enzyme complement that suggested to us that they would be good to try in the lab. So if you go to the next slide, we can indeed grow edible fungi on textiles. The only one we can't do is the button mushroom. The Agaricus bosporus will not grow on textiles in our current microcosm. That doesn't rule it out longer term, but it won't grow in our setup at the moment. The other ones that you can see here from the left, that's the shiitake, the middle one's the king oyster, and the one on the far right is the common oyster. The shiitake mushroom initially was very exciting until we realized that it's really hit and miss. You don't get a lot of reliability with the shiitake mushroom. Some of them grow extremely well and some really don't. The one that grows most consistently and is most exciting is the common oyster, the Pleurotus austriatus. If you go to the next slide, please. These edible fungi are also able to cope with the dye. Pleurotus austriatus is the one that really hit the ground running and just started taking the dye out almost immediately. But there's actually very little difference between the fungi over a 5-month period in terms of the amount of dye that they will remove out of the pants. If you go to the next slide, got an eye on my tie, I'm doing well here. So one of the downsides of this is how quickly it happens. So this is a piece of fabric that we have had the fungi working on for 2 years. So yes, it can take the dye out. This is now back to being completely natural coloured. There's no dye left in it at all. It's incredibly friable. It's completely destroyed the structure of the fabric, but we still have fabric. So if this is going to happen, it is not going to be a quick solution. This is going to be something that is a longer term means of getting rid of the textile mounting. If you just go to the last slide, Imogen, please. Can we grow mushrooms on old pants? No, we haven't yet. We've grown the fungi, we've got the hyphae, but we can't yet grow mushrooms. But I suspect that we're not far off. I think it's a tweak in our lab conditions, and we will get there, I feel. And I'd just like to finish up. I know I'm running on time here, but I'd like to thank Libby Hazelgrove and Rachel Harper, because they are 2 outstanding people that I've had working for me in the lab, and the success of the project has been down to their brilliance and commitment to, let's face it, is a pretty unusual research question.
Great. Thanks, Susie. That wasn't bad actually on time. So that's brilliant. I can't wait for the marketing campaign for these mushrooms. And I'm sure there's some people in the room thinking, would I eat them? Maybe someone wants to come in and ask about that in due course. But I think what was interesting about this was the application of something quite unusual to a really big problem, and working it through to see where it could be taken, and think through what might this mean in a broader sense for lots of other sort of sources of waste material or not so waste materials in the economy. So that's great. Thank you very much. So last but not least, I think Ian is here with us, and is going to go through a record number of slides in the shortest possible time without taking a breath. So it's something to behold. So Ian, do you want to introduce yourself? Tell everybody who you are. Most people will probably know you by reputation, and I'll only come in if I feel that we're going to run out of time on Q&A.
That sounds wonderful. Reputation. I've just taken over the screen, if that's okay with Imogen.
Yeah, that's great. Thanks.
Thank you. Yes, hello. I'm Ian Bateman. I lead something called the Land, Environment, Economics and Policy Institute here at the University of Exeter Business School. And
Ian, do you want to go into full screen mode? We're in speaker mode, I think. We can see all your slides.
Okay, let me just, is that
Yep.
any good?
Yeah, that's better. Great.
Thank you very much. Cheers. All right, given how little time and how many slides, I'm just going to get going. So I talked to Peter and he said that what you might be interested in is hearing about this initiative that we've got called SWEEP, Southwest Partnership for Environmental and Economic Prosperity. It's a highly multidisciplinary program in partnership with the public and private sector. What we're trying to do here is to use a variety of natural capital tools to improve decisions with regard to the environment, but also to try and make more profit for businesses, because we believe that if you can get that profit motive behind change, then it will have a sort of a self-reinforcing prospects and actually grow a lot faster. Do that by looking at all the consequences of decisions, by having specialist impact teams. And because of the nature of the initial funding we had, it's a place-based approach. So looking at actions in the Southwest, and you can see the variety of projects that were undertaken across the area, and undertaken with a huge array of partners. So I'll just literally, you can see there's just far too many to single anybody out, but in the end there was over 300 partners, organizations involved in this. The approach was very much to design the interventions that we had with the partners that were interested in this. So rather than, you know, academics doing the usual thing of saying, I know what's best, very much allowing businesses and the public sector to say, well, these are the problems that we've got. These are some ideas we've got for change. What can you do with that? And we had a variety of structures to make sure that the funding we had available was allocated on basically a cost-effective approach. We allocated money according to the expected size of impact that it would actually have. We produced a lot of services for the partners we were working with, things like natural capital accounting, trying to provide decision support for what they were doing. Some of this also was supplemented with some more sort of public and policy-faced communications, but I think that was just trying to build up wider interest in it. I think it was the actual tools in particular that we produced that had the biggest impact in terms of working with partners. Give you an idea of this with just one of those tools, and the detail that went into it. So this is with regard to land use change, people thinking about, in particular, planting trees. So understanding all the drivers of change, the things that have to be given up, the fact that we're part of an open economy, and for example, if you plant trees in one area and you reduce the amount of food being produced, that doesn't actually help the planet if it just results in that food production being shifted to Amazonia, and for every tree you plant here, you fell 3 in the Amazon. Trying to look at okay, what are the incentives that farmers in particular here would need to actually make this change. This was a tool that we produced for DEFRA. That gives you a massive array of future land use options, almost infinity of options, and you can then begin to think about what are the other things I'm going to do with this land. For example, obviously planting trees is a big one these days. Have to think about the fact that trees interact with their environment, that actually the effect that they have even locally on greenhouse gases varies enormously depending on where you plant them. You can actually plant trees that net will emit carbon dioxide because of their interaction with the land. So you can really mess this up. So you've got to bring it in. Very keen to think about the fact that a lot of these investments take a long time to pay off. Have to bring that in. And also they're going to affect lots of other things. Biodiversity, water, recreation, that sort of stuff. And a lot of the businesses that are associated with this. Now, all this is just far too complex for anybody to do on the back of an envelope. So one of the main things that we did was to design decision support systems with these partners so that they could actually play around with them themselves and actually find out what the consequences of different land uses would be for them. What are the costs? What are the benefits? A very wide variety of projects using this methodology. So out in the marine environment, coastal, river catchments, lots of land-based projects, and lots of projects just focusing on people. I'll give you a link to all of these at the end. What impact did we generate? So we received funding of £5 million from the government. Once people realised what this was doing, we actually received a larger amount of money from the business sector itself. And you can see from the paybacks that this generated, so this is after 6 years, that it's a phenomenal investment. You know, you've got rates of return here that are only comparable to sort of rural broadband in terms of their payoff. If you are interested in finding out more, just go to sweep.ac.uk. All of the case studies that I showed you are on there. A lot more information about the tools that we generated and information about how these applications can be applied further and into the future. Thank you very much.
Great, thanks, Ian. We've got about 20 minutes left. I saw some questions that came in on the back of Susie's presentation. I'm just going to take Chair's sort of privilege here and ask a question that links you and Carl together. So one of your studies was looking at alternative approaches to flood risk management, which Carl presented on, and your North Devon Biosphere project was the application of natural capital accounting. So it's a joint question here. So to you, Ian, can you tell us a little bit about natural capital accounting and treasury rules for why your approach is so important and could help unlock the sort of the way we think about flood risk management in the future? And then back to Carl, from an environmental agency perspective, you know about the North Devon Biosphere sort of application. So why isn't the Environment Agency using natural capital accounting to drive change faster and at scale? What's holding you back? So about these particular ways of measuring, quantifying, evaluating outcomes that are necessary to unlock investment and policy. And then we'll go to the questions to Susie. So Ian, do you want to just sort of pick that up, and then to Carl?
Well, actually, rules have really, well, I would say improved massively over the last, let me see, I'd really say that the 2018 Green Book edition was a landmark. So the Green Book is the guidelines from HM Treasury that have to be applied to public spending. And they basically say you've got to look at all the costs and all the benefits. And they've been saying that for, I remember looking at the 1972, so I predate even you, Peter, guidelines. So it's been around for a long time. But what has really changed is the emphasis put on doing this, if you like, a bit more seriously, particularly with regard to the natural environment costs and benefits. Also, at the same time, there has been a big advance in economic analysis techniques. And I'm not just talking about valuation methods, which get a lot of press, but also just the ability to bring very large data sets together and look, for example, at how water moves through a catchment, how changes in, for example, farming in certain areas will or will not have impacts upon the water quality downstream. But I will just finish with one caveat that quite shocked me in the course of doing SWEEP. We did a project on SUDS. So, oh gosh, what's it called? Sustainable Urban Drainage Systems, I think. Yeah, sorry, I just used the acronym so much. And I was just amazed to find out the disconnect between what happens in the urban area and what happens in the rest of the catchment. It's like they are treated as if they are on different planets, really. Well, that's okay, that's a little extreme, but there isn't really that coherent decision making that you might expect when, quite obviously, what happens upstream in a catchment is going to affect what happens in an urban area, and often the urban drainage is almost sort of catching up from that. So we do need to change the sort of procedures we use, as well as implementing these rules.
Okay, great, Ian, thanks for that. And then there'll be a link to that case study for anyone who wants to follow it there. But Carl, over to you. What's going on in the Environment Agency in this area?
Yeah, so I think we do deal with it. Well, as one of my slides showed, it does crop up from time to time. I think there's a couple of barriers as to why this isn't adopted more widely, and one of those is cultural, and then the other one is actually around funding rules rather than economic appraisal rules. So on the cultural side, as Ian's just said, actually a lot of projects are just focused on the project, and are not necessarily thinking about that sort of wider catchment sort of systems approach. That's one problem. Second problem is traditional economic appraisal approaches. So natural capital is, we do actually have guidance around applying natural capital to flood risk management projects, but it's still presented as a bit of an outsider. It's here's the traditional approach, and if you want to do that natural capital thing, there's some guidance over here. So we're still stuck in a tradition of doing that. On the funding side, it's still quite a sort of silo mentality. So those in charge of funding flood risk management are quite adamant that primarily that flood money, if you like, if we'll call it that, needs to be spent on flood risk benefits. So if you present a case that goes, we've got some flood risk benefits and this amazing suite of wider benefits, they go, yeah, but we're just paying for the flood bit and maybe just a little bit of the additional benefits. And so again, there's a sort of cultural thing that's partly government, it's partly in the Environment Agency of getting them to think more about systems and interactions, which I think is quite fundamental to achieving more sustainable approaches.
Great. Okay, you've got a new chairman and a new chief executive, so your job is to persuade them to shift that culture. So that's great. So let's Bob, Nicole, and Severine came in quick fire to ask Susie some questions or make some observations. So Bob, are you there? And then Nicole, Severine, do you want to fire your questions at Susie for a 3 on the trot?
Yeah, hello, can you hear me?
Yeah, great.
Yeah, I was just wondering, once the pants have been degraded to a certain extent, so they're non-coloured, could they then be used in another way or reused in some other way or treated differently? Because time is a really rate limiting factor when it comes to waste treatment. And the idea that we'll have the capacity to treat things for over a year or longer into the future, especially when we're buying so much textiles and running through pants at quite an alarming rate, I imagine. Is there an option? Is that just a first stage? Could it be a first stage in a process? Could the scraps of fabric move on to something else or be used for something else.
Do you want me to answer that straight away, Peter, or did you want everyone to ask?
No, go on, go for that one because it's quite an interesting.
Okay, so it might answer. I had a quick sneaky look at the other questions as well, so this might answer some of that. The idea isn't that we use this for dye bioremediation. The idea is that we completely mineralize the fabric, in which case, if we're right and if we can get mushrooms to grow on the textile waste, what is the rush? If we've got a source, which is a mountain of fabric, which quite happily you've got fungi growing through it and they're taking the dye out, yes, but they're not just taking the dye out. That's the bit that we can assay. And the bit that has caused me a lot of headaches is the fact that we can't assay what they're doing to the fabric, but we can see the physical changes over time. Now, if we can get them to produce mushrooms, then we're saying, well, actually, okay, this mountain might be there, but it's providing a food source. And then it becomes a crop. And then it doesn't become an issue. You're getting rid of something by creating it to have value, which I think is the really driving thing with this.
Sorry, Susie. I was just wondering, okay. Have you contacted an expert in mushrooms? I forget what they're called. To ask why aren't you producing actual fruit?
The next step would be to actually start developing links with mushroom farmers. But we needed to know that we could do edible fungi first. Yeah. So the concept is something that nobody else has done. It's just something that I dreamt up and sort of brought my lab group along with. So it is completely new. There's nobody else that's done this. It is, I mean, we've published one paper on it. There's another one about to be submitted with the stuff you've seen today. This is new, but if it works, it's a really big deal, particularly because, as I alluded to in the talk, the vast majority of the problem sits outside the UK. It sits in LMICs, where there isn't the technology to then be able to go, well, look, we can take this and perform some complicated process and make something of value. Actually, what's more valuable is a good source of protein, which mushrooms are. And like I say, if you've got a constant production of mushrooms, then actually the time it takes is less of an issue. I noticed one of the questions was around, well, would you actually want to eat them? And the answer to that is yes, as long as I've been allowed to analyse them first. I would not eat a mushroom that I thought contained microplastic, which is the biggest factor, I think, is that actually the full degradation wouldn't happen and that some of those synthetic fibres would be pulled over and sort of incorporated into the fruiting body. And if that was the case, no, they wouldn't be fit for human consumption. That doesn't take away the value of the process, because as you might be aware, I'm aware, because obviously I read everything to do with fungi, but there are a lot of other things that you can do with fungal mycelium. So even if we can't produce mushrooms, we could produce something of value. And things like mushrooms that, or fungal hyphae that are being turned into bricks, into packaging. Strangely enough, nobody really seems to be taking on the idea of turning them back into fabric, which for me would be like the ultimate justice, is that we get to wear them. But there are lots of other applications being looked at for fungal hyphae to be used for something of value. So even if the idea of eating our own pants doesn't appeal, actually that doesn't take away the value of doing the work.
Okay. I think there may be some technical issues there that you and Bob need to sort of work out offline. I think you may have picked up Nicole's question. Nicole, I hope that may have answered the question. If not, come back in. But Severine, has it answered your question, or did you want to sort of extend the challenge back to Susie?
Thank you. It has in part, but so if we have all these mountains of mushroom, provided that, what if they're not edible? So if I understand you well, the dye, you might not, is the main problem with recycling it. So if in the meantime, can it also be used? Can you use what you've got in order to recycle better, to be disposed of better, or even be used again in other forms?
What, the fabric, you mean?
Yes, once the dye has...
No, it seems to take, it seems to metabolize part of the fabric along with the dye. I think the dye is easy pickings for a fungus. It's very easy for them to pull out and break down. So I guess the other flip side of it, if we're looking at how you could build value into it, how you could make it more circular, is the work that we're beginning to look at now, which really is like the last couple of weeks of analysis, is looking at, well, what do they break down the dye into, what are the intermediates, and actually the fungi are producing a lot of very interesting compounds, which, given some more serious biotech rather than harvesting mushrooms, we could actually be looking at harvesting some of the compounds that they produce that may have interesting uses in things like the pharmaceutical industry or cosmeceutical industry, which again would valorize the fact that we've got mountains of textile waste. Fungi are the answer, whichever way you look at it.
Oh, right. Okay. Did you always grow up wanting to be a fungiist? From a young
I think there was definitely a streak there. Yeah.
Yeah. Okay. I mean, the very first case study I came across in the circular economy back in 2009 was Ecological, who you probably know, mycelium packaging to replace styrofoam. And everyone at the time said, "Ha ha, what a niche little." And it's now that Ecological it's now a multi-billion-pound business. Two American young researchers from MIT started to grow mycelium onto wheat straw. They were both farmers out of the farming background and started to realize that you could grow them and mold them into packaging to replace styrofoam. So, you know, eat your packaging as well as your pants. It was that sort of, that was the strap line of the time. So, okay, Matthew has asked a question, then Bassem has asked sort of a slightly different question, which I think we can pick up and see whether anyone wants to have a go at it. But Matthew, you just wanted to ask a question about Sweep, where the funding is finished, but do you want to come in and just sort of ask Ian? Matthew Freeman?
Yeah, hi. Sorry, I wasn't expecting. Let me find my question.
Okay, there you go. Yeah.
Where did I put it?
12:40.
Oh, I think my question. Well, my question is now you've successfully sort of established Sweep. If it's Sweep, is that going to be rolled out across the rest of the country, and then we sort of advance what you've learned there and what you've applied, and have something similar set up across the country in sort of different segments so that everybody can sort of learn and develop to your sort of good example?
Thank you very much. Yes, is the answer. Not as much as I'd like, but you know, still pretty good. So there are now programs following this design in Birmingham, London, and Yorkshire. And I believe that there's a good chance of others being set up. The way to find out about it is go to the NERC, that's Natural Environment Research Council, website and search for their RISE program, which I'm afraid I can't remember what that stands for, but it's the program that this is funded under. And you'll see that they are indeed putting more funding into this. As I say, not as much as I'd like, but the other projects that are funded are as big as Sweep was. So, you know, at least it's slowly expanding.
Okay.
Cool. Good. Thank you.
Got about 5 minutes left. But Bassem, did you want to ask what you call your generic question?
Yeah, thank you for giving me this chance. First of all, this is a really good session. Thank you for preparing it. I just would like to talk about my research, which is related to circular economy strategies. But my question is quite different about what you've been talking about. It's about the micro level rather than a macro level. So could we, my research is about how circular economy strategies can help SMEs in conflict zone to be more resilient to achieve internationalization. I'm trying to apply my research about Palestine as a conflict zone, and the conflict in Palestine is unstoppable. So I would like to help SMEs there in this conflict zone to internationalize, to help economic growth by using circular economy strategy.
Okay.
So any recommendations there to help?
Okay, so the way I interpret that, Bassem, is are some of the ideas that we've been talking about, are they transferable into an international context, particularly conflict? Are they appropriate for SMEs, and are they likely to be more resilient than other techniques? But so does anyone want to sort of just dive in and give a quick answer in the time we've got available?
I'll give it a go very quickly. So Bassem, the average firm size in the southwest of England is 3. That's the average number of employees. So there are a lot of SMEs down here, and we worked with many of them. So I said there was 300 partners. Actually, that was excluding the huge number of people working in the agricultural field, which are often sort of one-man bands. Trying to understand what the full effects of your decisions will be is always a good idea, because it will allow you, even from an individual point of view, to try and using the term that Susie coined, valorize. I like that a lot. It actually allows you to look at what is happening in the real world and to try and see how you can actually turn that into private value. And private value is not a bad thing with this. If we can actually make natural capital solutions that make businesses better off, those are the ones that are going to be successful. So yes, I think this is very applicable. Thanks.
Carl.
Thank you, Edmund.
Carl, did you have anything to add before we finish?
I think I have, Peter. Thank you.
Yep. Okay, great. I mean, my answer to that, Bassem, would be that, you know, a lot of the early thinking in circular economy, which derives from things like cradle to cradle, blue economy, regenerative design, previously natural capitalism, as you keep going back in time, a lot of them are actually driven by small scale innovations outside of a Western industrial model, and particularly around things like water supply, water treatment, food supply, about how do people survive in difficult conditions and use their resources to maximum benefit. So we can send you some links to some case examples that we cover in courses that we run around that whole resilience and international global south dimension. I mean, Palestine's a tough issue, you know, a tough country where, you know, facing lots of challenges. So let's dig some things out. Susie, any last comment from you before we close down?
No, thank you for having me, and thank you very much for everyone's enthusiasm.
Great. Okay, so a digital round of applause for our 3 speakers. And also some great questions. Thank you very much. Thank you for giving up your time and helping us sort of explore this vast topic, but some really practical, actionable sort of things that are happening, and some futuristic sort of mushrooms coming our way soon. So Susie, keep us posted for when they are ready, and we'll invite you back for the launch. Okay, so thanks everyone, and enjoy the rest of the day wherever you are, and hopefully see you in another webinar in the near future. Okay, bye.
Thank you.